You've been tasked with fixing a failing software project, or at least determining why the code has little or no value. If you think you have the technical experience required, you don't, but neither does anyone else. Welcome to the dark side of the leading edge. My name is David Wally, and I have over 40 years coding experience. The contents of this video are my opinions based on experience with code-based rescues and ongoing study. I know dozens of languages and technologies, but there are far more I know nothing about. Sometimes a language type or development style is evident from my statements, but I try to be as general as possible, covering trends and patterns I have seen in multiple languages and frameworks. Every failing project I have seen, heard of, or read about is totally unique. That means no one has experience with a combination of problems in your project. Experience with good code helps, but is not what you are faced with now. Experience with bad code is better, but never enough because there are so many possible mistakes. Shift gears now from the optimistic mindset of creating shiny new code for a happy project to the dark side, from designer and builder to a crime or accident scene investigator. This video adds to the list from my first video of questions to try to answer, this time from more of a tech background. The big question of fix, abandon, or find some middle ground is likely to hang over the project for some time. As you get deeper into the code and technical issues, you will probably find more issues to assess. Somewhere there is at least one huge entanglement or misunderstanding or foundational mistake. Among a project's problems, there will be several familiar ones and a few to add to the long list of things not to do. However, you need to look at things you can do with this failing project now, not woulda, coulda, shoulda done. Your attempt at a fix is a project itself and should follow principles of good project management. Chief among them is understanding and balancing a triangle of concerns: budget, schedule, and target product. Risk management is also important, especially in a failing project. You can find much more about these topics with a simple search of the internet. I assume you have some experience, and there are many best practices you are familiar with or wanting to try. However, making too many changes or trying too many new things at once is a well-known risk in itself. Abilities and experience of continuing or new team members, including yourself, need to be considered carefully. As unique as your approach has to be, start with the most important practices, like using a version control system properly and a bug tracker. Some important procedures, like product specification and design steps, were likely skipped or botched. You can't go back in time, and you don't have much time, but you definitely need to determine, is the project actually failing? Or is this a case of unreasonably high expectations and promises, perhaps set by non-coding sales reps or an inexperienced coder? Perhaps there is no agreed upon list of features or use cases, or the list is expanding uncontrollably. It is common for failed projects to have gotten off to a fast start, because many frameworks are tuned to do this, to get the go-ahead. Plus, the team might tackle the easiest and flashiest tasks first, but this can create unrealistic expectations, especially if overall design, note-taking, and coding of tricky and risky parts are put off. These problems are more than just technical and require more than just a technical solution. Good luck with that. Too many projects are failing worldwide, even though most look like or say they are following best practices. Either many leaders misunderstand, which happens, or the best practices aren't that good, which also happens. Either way, on a failing project, question everything, including what you assume are best practices. Something has gone horribly wrong. Is it a normally good idea that has been twisted or taken too far? There are some outstanding questions that need to be answered and require some tech expertise. The big three: lines of code, bug tracking, and automated tests. How many lines, files, and folders are there? What formats? How are they organized? Who owns them? What is handcrafted and what is or was auto-generated? Harder to see immediately, but a serious problem. What code was copied, pasted, and then modified? Start a list and add notes as you find out about the contents of files and directories. Is there a bug tracker? How many outstanding bugs are there? What is the fix rate over time? What quality is the average report? Is enough info being entered and tracked? How many automated tests are there? What testing frameworks are used, if any? What types of tests are there? What's the coverage percentage? And most important, can you understand the tests? With this technical information answered as best you can revisit the question of fix, abandon, or find middle ground. If forging ahead with a fix, I look next at whether to try fixing outside in or inside out. By outside in, I mean fixing the bugs entered in the bug tracker, identifying more bugs through testing, and keep fixing. In other words, you and the team continue with normal, if debug-focused development, and do better than the previous efforts because of new skills and experience on the team through new team members or continuing team members ready to learn. If an honest assessment leads you to think you can fix enough in the time you have, then go for it. By inside out, I focus on reading through source code and fixing what looks wrong, whether a known bug or not. The advantage of this approach is it can lead to a complete high-quality fix, or a fast fail. I describe it as reading all source code from top to bottom, but in practice I jump around, following various threads through the code. Perhaps execution flow, or variable or function, or whatever looks to be most productive for deepening my understanding. Along the way, I take and leave notes, just like in school. I throw out any notion of clean code and think crime scene investigation instead. I want to understand the ugliness and preserve evidence, not prettify and wipe clean. But the team also needs to organize, visualize, catalog, and connect the evidence and your notes, just like any good team of detectives. I use tidy code, rich and dense, with a database-like structure, combined with clear visual layout of tabular and structured relationships. I'll look at that closer in another video. If the language allows it, I use inline comments only to connect each code statement with its purpose, just like two columns in a properly designed database or spreadsheet. Also, I can tell at a glance which lines I, or a current member of the team, has read and explained to our satisfaction, not the satisfaction of the author of the mess. By the time I have read and explained most lines in the project, renamed poor names, untangled convoluted code, fixed what I can, and done some cleanup debugging, the project is working or back on track again. But if the code has too little value, that becomes clear very soon. Of course, this only works if the project isn't too big for the time available, minus any time to get up to speed. But a top-to-bottom review and inside-out fix can be a fraction of the cost of a rewrite from scratch. It works surprisingly often, usually because no one else has bothered to read all the source code. Code reviews did not occur or were for checking standards and compliance, not simplicity and clarity. Integrated development environments often present the source code in pieces, hiding complexity with convenient features in some submenu. A coder can spend years looking at pieces and never get the big picture. If the project is just too large to fix in one sustained effort, there is still hope for the inside-out strategy, but you have to automate. Automated testing is hugely important because it allows safe refactoring, making major changes confident that you are not breaking anything. The existence of enough good tests, or the ability to write new ones, can be a deciding factor. But tests are not the only automation you need. Start thinking of your code base as a database. The source code is input data to be fed into a bug-fixing program. Outputting new source code in a tidy database-like format, indexed in several ways so it can be viewed in several ways, for production code, testing, documentation, rich searches, or custom tests. There are existing programs for parts of this job, checking code and finding, if not fixing, specific problems. You may be able to cobble together a unique set of programs and custom code that gets you most of the way to the finish line. This custom code is a bodge, throwaway code with limited or no use outside of your unique project, because it only needs to work once, but you want the ability to run it multiple times, so you can check, tweak, and verify the fixes being made, and reprogram and rerun if needed. I am sharing what code I have on GitHub, but it is not as extensive or as general purpose as I would like. You will have to write some code of your own. Perhaps you can share it if you make it general enough. If you can't fix everything in one sustained effort, then you will have to perform checks along the way. And for that, automated tests of some kind are needed. Human testing, including ad hoc manual testing by the coder, is not fast enough nor reliable enough, and not easy enough for extensive refactoring. If your project has significant automated tests, then there is good news and bad news. The good news is you should have what you need to start refactoring. The bad news is the test didn't prevent your project from failing, so you need to take a closer look at the tests. Automated testing frameworks have caused failures because of misunderstandings of how to use them. This results in time wasted creating tests, potential wasted time trying to debug tests, and poor morale for coders not seeing any benefit and dreading them. Some testing frameworks require significant learning. On a failing project, it's likely the team did not find the time or the expertise. In particular, changing the structure of main code to make test code work is a red flag and very common. As a start, look for public functions that should be private, if that makes sense in your language. If you have no significant tests, then you probably should start writing some. It is probably too late for the many tests that cover 100% of the code, but you should have a reasonable sense of what is needed from seeing what is dodgy in the code and what is reported in the bug tracker. However, the goal is to make refactoring possible, that is, safe, and there might be other ways to increase your refactoring confidence level. I'll take a look at some refactoring techniques and tests in the next video. I hope you have a better sense of your options and a better idea of the technical answers you need to find.